Listen up, agents. Consider this your highly classified briefing. You're stepping into the shoes of a tactical extraction specialist today. But the hostile territory you're dropping into? It isn't a laser-guarded bank vault. No, it's the Cambridge Information Technology 9626 Paper 2 exam. Your absolute highest value target for this mission is securing the maximum possible marks for what is widely known as a notoriously tricky topic, 3.1 sensors. We are talking specifically about sound, infrared, touch, electromagnetic field, and proximity sensors. Now, across all the Cambridge syllabus codes, whether you're battling through 0417, 0478, 2210, 9618, or 9626, the examiners are actively hunting for precise, analytical, scenario-based answers. The problem is, most students walk into this exam completely unarmed. They treat it like a basic middle school vocabulary test, they see the word sensor on the page, panic, and just start dumping raw, memorized textbook data everywhere. And honestly, that is a fatal error. Today, we are going completely tactical. We're going to transform you from a vulnerable target into a master strategist. We're going to deconstruct the exact examiner playbook, decode all their little traps, and make sure you extract every single mark you are owed from this paper.
Now, I want you to really notice the sheer weight of what we are dealing with here. Look at the data. The 3.1 sensors topic accounts for approximately 15% of the total marks in Paper 2 of Information Technology 9626. 15%. Just let that sink in for a second. In the absolutely ruthless world of Cambridge grading boundaries, 15% is not just some minor bump in the road. That is literally the entire chasm between a C and an A, or the difference between an A and that highly coveted A star. You simply cannot afford to drop points here. When you lose marks on these sensor questions, you are essentially bleeding out on what should be the most straightforward technical application questions the paper has to offer. But to secure those marks, you really have to understand one fundamental truth. The examiners are not just testing your memory of what a sensor is, they are rigorously, ruthlessly testing your methodology and your critical thinking.
So here is your exact mission roadmap for today's explainer. First up, we'll tackle the 15% challenge by looking exactly at how and why most students fail. Second, we're going to lay down the theoretical foundations so you understand what the mark scheme actually demands from you. Third, we'll construct the procedural framework, which is going to be your bulletproof method for structuring answers. Fourth, we'll enter the critical analysis strategy workshop for some high-pressure data interpretation. And finally, we will wrap up our debrief with the top examiner warnings drawn straight from the principal examiner reports.
Okay, Phase 1, the 15% challenge. To truly understand how to extract maximum marks, we have to study failure first.
Meet our two compromised agents in the field. We have Alex, who we'll call the data dumper, and Sam, the sprinter. Now, Alex has memorized the entire textbook cover to cover, knows every definition. But Alex has absolutely zero analytical strategy. Sam, on the other hand, has really great ideas, but always panics under the ticking clock and completely ignores the command words in the prompt. When we look at their answers side by side for a standard 6-mark security system question, it's a disaster. Both of them are just bleeding marks on the battlefield. Look at Alex's side. It's a generic fact overload. Alex writes, infrared sensors detect heat. Sound sensors detect noise. Look at all that virtual red pen from the examiner. Alex gets maybe one single mark for basic knowledge, but there is absolutely zero application to the specific scenario. Now look over at Sam's answer. The command word for this question was evaluate the use of an electromagnetic field sensor. Sam writes, the EM sensor is good because it detects metals, so the alarm goes off. Massive red ink again. Why? Because Sam completely missed the context of the word evaluate. Evaluate requires looking at both sides, the pros and the cons, and providing a justified conclusion. It doesn't matter how good your underlying technical knowledge is, if you fail to decode the command word, you lose the points, period.
Which brings us right into Phase 2, the theoretical foundations. This is where we figure out what is actually going on inside the examiner's head.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so to avoid the massive traps that Alex and Sam just fell into, you really have to understand that the assessment objectives for 3.1 sensors target 3 distinct cognitive domains. You need knowledge, application, and analysis. Top-tier students hit all 3 of these domains by structuring their answers using the PEEL framework: point, evidence, explanation, and link. And I want you to pay close attention to this massive insight we pulled directly from the Cambridge Principal Examiner report. It says, candidates referencing cross-topic connections achieve significantly higher marks. This right here, this is your secret weapon. Think about it. If the exam question is about using a touch sensor on a restaurant point-of-sale terminal, a basic student just says it registers the touch. But the top 1% of students, They link that touch sensor input to network data transmission, security protocols, or live database inventory updates. That cross-topic synthesis is exactly what turns a decent answer into an absolutely outstanding full-mark extraction. To actually execute that level of synthesis consistently, you need a highly reliable system. Enter the deconstruct, solve, evaluate framework. This is the absolute essential strategy for securing method marks. Whenever you are faced with a complex sensor problem, I want you to follow these 5 steps systematically. Step 1. Identify the given information in the scenario. What are the environmental conditions? Is it a dusty warehouse, a freezing cold room? Step 2. Break the problem down into logical steps. Step 3. Solve systematically by selecting the correct sensor. For example, choosing a passive infrared sensor instead of a touch sensor for a highly hygienic hospital door where you want to avoid physical contact. Step 4. Always check for reasonableness. Would a sound sensor actually work reliably in a factory where heavy machinery is running? Probably not, right? It would trigger constantly. And finally, Step 5. Make justified recommendations based on your analysis. Using this framework guarantees you are hitting every single cognitive domain that the exam demands.
Moving on to Phase 3, the procedural framework in action. Let's see how this actually works. So, the procedural framework isn't just about what you write down on the paper. It is heavily about how you present it. Practical application in the 3.1 sensors topic demands incredibly strict presentation conventions. Think about the examiner. They are processing hundreds, maybe thousands of these papers. If your answer is just a massive, chaotic wall of text, you're making it so much harder for them to actually award you marks. You have to display professional skills. This means using proper headings if the question demands a report format. It means using precise, correct terminology. Never, ever say something like, "the sensor feels things." You are a computer science student. You say, "the touch sensor detects physical contact or pressure." It also requires appropriate formats and super clear annotations if you are asked to interpret or draw a diagram. Listen to me on this. Failing to use these professional communication skills will literally cost you marks, even if your underlying IT knowledge is technically flawless.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back to the Briefing Agents. It is time to initiate Phase 4, the Critical Analysis Strategy, and our Visual Data Scan workshop. Because knowing the theory in a relaxed environment is one thing, but performing while that clock is ticking down is entirely different.
All right, you have 60 seconds on the clock. Look really closely at the data in front of you. We have sensor type, output in millivolts, distance in centimeters, and response time in milliseconds. What is the core trend happening here? Applying your deconstruct, solve, evaluate framework, I don't want you to just read the raw numbers. I want you to actively look for the relationship between them. Notice how, specifically for the proximity sensor, as the distance increases, the output voltage drops off exponentially, yet the response time stays relatively static. This is exactly the kind of analysis they want. If an exam question asks you to justify which sensor to use for a high-speed, close-range sorting conveyor belt, you must extract this exact piece of evidence. You would argue that the proximity sensor is the optimal choice because the data clearly proves its response time is sufficient at low distances, generating a high enough millivolt output to reliably trigger the analog-to-digital converter. That is exactly how you draw a concrete, evidence-based conclusion when you're under pressure.
Let's run another exercise, a quick Find the Flaw challenge. I want you to compare the 2 statements shown right now. This right here is what separates the novices from the absolute masters. The flawed statement on the left says, infrared sensors detect heat. Now, why does this instantly lose marks? Because it is floating completely in a vacuum. It is a purely descriptive level answer. There is zero analysis. Now review the perfect statement on the right. The IR sensor detects motion in the specified 5-meter hallway context, triggering the microprocessor to compare the input against the baseline ambient temperature. This perfect sentence does 3 crucial things. It names the specific technology. It anchors it directly to the 5-meter hallway scenario provided in the prompt, and it explains the actual causal system trigger. The examiner commentary constantly, relentlessly states that context is king. If you strip away the context from your answer, you are stripping away your marks.
All right, the pressure is really turning up now. This is the speed writing challenge. You have 30 seconds on the clock. I want you to mentally draft a fully evaluated conclusion for a scenario where an electromagnetic field sensor is being used to count cars entering a parking lot. Go. Think about it. You need to evaluate the quality of the evidence. What are the actual limitations of this setup? What assumptions are being made? A standard mid-tier conclusion would just say the sensor counts the cars well. We don't want mid-tier. A top-tier evaluated conclusion using the Peel framework would state something like, while the EM field sensor effectively counts large metallic masses, a significant limitation is its potential failure to register non-metallic vehicles or its susceptibility to magnetic interference from underground power lines, which could severely skew the final database count. That right there, that is how you evaluate alternative scenarios and secure those final elusive evaluation marks.
Okay, moving into our final phase. Phase 5, examiner warnings and the top fatal mistakes. Because honestly, even with a perfect theoretical system, students still walk blindfolded right into examiner traps. Let's look at the direct intelligence we've gathered.
The examiners are essentially screaming this from the rooftops, year after year in their reports. Here are the top 3 fatal mistakes you must avoid. Number 1, using the wrong approach for the context. We talked about this. Recommending a highly sensitive sound sensor in a bustling, noisy warehouse environment shows a complete fundamental lack of situational analysis. You'll get 0 marks for application. Number 2, forgetting your format and presentation. If the prompt specifically asks for a comparative table of touch versus proximity sensors and you write a massive block text paragraph, you lose marks immediately. And number 3, the ultimate trap. The absolute destroyer of exam grades. Providing generic answers that are not specific to the context. I really cannot stress this enough. If your written answer could theoretically apply to any generic sensor question on the planet, it is wrong for the specific question sitting in front of you.
Seriously. If you take absolutely nothing else away from this entire explainer today, burn this golden rule into your memory right now. Always link every single point to the given scenario. To hit those higher-order assessment objectives in Cambridge IT or computer science, your precise technical definitions and your causal relationships must be permanently anchored to the scenario on the page. If the exam is about an automated greenhouse, every single time you mention a temperature, humidity, or light sensor, it must tie directly back to the plants, the automated greenhouse windows, or the electronic sprinkler systems. Context isn't just a suggestion. Context is the literal key that unlocks the highest mark bands.
So, to wrap up our intelligence briefing, remember your ultimate cheat sheet system. 1. Decode the command word immediately. 2. Deploy your peel or deconstruct solve-evaluate framework to structure your logic. And 3. Use your time management matrix to allocate minutes based strictly on the marks available. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. I leave you with this final critical thought. The very next time you see a 6-mark sensor question sitting there on the exam paper, are you going to freeze and just fact dump, or will you extract every single mark like the tactician you now are? Ace the Exams. Your Cambridge success starts here.